Okay, so this is just a quick review on binary, especially if you missed this past week or if you're unsure on how to complete the alphabet learning assignment. So the normal system that we use is called decimal or denary system. Oops. So we're used to place values. So all the way over on the right, in our normal system, we have the ones, tens, hundreds, and thousands. And we use 10 different numerals or 10 different numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And with those 10 different digits, we create a whole host of different numbers. So, for instance, here, the 4 tells us that there are 4 ones, 9 tens, 1 hundreds. And this is a system that we're used to using. Binary, bi means that we only have two numbers, and we have zeros and we have ones. So instead of having each value be the placeholder, or I'm sorry, instead of having each value be based off of 10, we have it based off of base 2. So if we look up at this very top row, these are our place values. So all the way on the right, we have a 1, 2, 4, 8, 16, 32. In our normal system, it's ones, tens, hundreds, thousands, 10,000s, etc. So because we can only use ones or zeros in our numbers, we use them in a way to tell us if that value is going to be added in or if it's not. So looking here, again, these are my values, or my place values. So again, 1 is all the way over to the right, and as it moves to the left, it doubles. So 1 doubled is 2, 2 doubled is 4, 4 doubled is 8, 8 doubled is 16, 16 doubled is 32. And as we kept going, it would keep doubling. So 64, 128, 256, 512. Some of these numbers might sound familiar to you because they're also usually the RAM or storage sizes for hard drives. So just refreshing back to Unit 1. All right, so looking here, if I have a 0, that means that the value is off. So that means it's not going to get added in. So here I have this binary number of 0, 0, 1, 0, 1, 1. So that means the 32 is not going to get added in. The 16 is not going to get added in. The 8 is on, so it will be added in. The 4 is not. The 2 is on because that 1 is there, so that means that it's going to be added in. And then the 1. So the value of this binary number, so the value of 001011 is 8 plus 2 plus 1, which is 11. So again, if the 0 is in there, that value is off. If the 1 is in there, it is on, which means that it's going to get added in. So how does this relate to your homework assignment? So you see here, your binary to alphabet. One thing that I didn't necessarily say is that each one of those place values is considered a bit. And a bit is a binary digit. So for instance, in this homework assignment, we're using 5-bit binary. Most computers run off of higher binary. This isn't really a thing, but for us to learn, it is. Remember that 8 bits. So if there was 8 zeros in that very first one, it would equal a byte. And then we can start talking about storage sizes. So here, I want to get the number 0. So I have all zeros being shown. To get the number 1, I'm going to flip over my cards until I get the value of 1. So I could flip them all the way over. However, I know that the binary number all the way to the right is the smallest one we have. So that means that the binary number for 1 is going to be 0, 0, 0, 0, 1. The first letter in our alphabet is A. So going over to the next one. So basically with this assignment, what you're doing with those cards that you have in front of you, again, with those cards that you have in front of you that we made on Monday, we made again on Tuesday, there was time again on Friday. Hopefully you've made those cards. They should look just like the cards I have here, where each one has a specific amount of dots. Again, 16 is all the way up to the left, 8, 4, 2, and 1. So 1 is all the way over to the right, and then you double as you move to the left. So for this assignment, really what you're doing is you're just flipping over the cards until you get the value that's here in this first column or in the base 10 column. So here for 2, it's going to be 0, 0, 1, 0, and that's going to be B. All right, so I know that 3 is just one more, and I know that that 1 isn't flipped over yet. So I can go ahead and flip it over, and that means for the base 10 or the decimal number 3 in binary, that's going to be 0, 0, 0, 1, 1, and it's going to be C. So essentially all you're doing is flipping over the cards until you get it to equal the number you want. Once you get it to that number you want, so say if I was trying to get 12, let's go ahead and do 14 because it's the next one up here. Once I get that 14, I'm just filling in what's being represented up here. Oh, ignore that. I'm trying just to get what's represented, or where the zeros and ones are showing. That's what I'm going to put in this binary one. I think the 14th letter is O, maybe, or N. I would have to go back through and go all the way through the columns, but 0, 1, 1, 0, 8 plus 4 plus 2 is 14. So again, for this assignment, you have your cards in front of you and you're just flipping over until you get the correct number that you're looking for in the base 10 column, copying down the order of zeros and ones, and then attaching a letter to it. When you get down to the bottom, you're going to spell out Amundsen. So an example here, and I want you to press enter after each number or letter. So here I have high, which is 0, 1, 0, 0, 0 is the number 8, which represents the letter H. 0, 1, 0, 0, 1, 9, 1 is I. So after you get this graph filled out, what you can simply do is just come up here and copy the number you have and then go all the way down, and you can spell Amundsen that way. Right, again, if you have any questions, let me know. We are going to be using this graph on Monday, January 11th, to write secret notes to each other.